Hey there and welcome. So let's talk about something we've all been through. That feeling of just being buried under a mountain of raw numbers. It's a lot, right? But don't you worry. By the end of our time here, you're going to have a simple, really powerful toolkit to make sense of it all. So let's dive in and start building it. I mean, it's such a common feeling, isn't it? You get handed a spreadsheet or a report, maybe just a long list of scores, and your eyes just kind of glaze over. It honestly feels like you're staring at some secret code that nobody ever gave you the key to. Yeah, just look at this string of numbers. It's just a jumble. What does it even mean? Are these good scores? Are they bad? Are they all clustered together? Or are they totally all over the place? You really can't tell just by staring at it, can you? Well, that's the exact problem we're going to solve right now. All right, so the very first step to making sense of any data is always the same. You've got to bring some order to the chaos. So let's reach into our toolkit and grab our first tool. Now this first one, frequency distribution, I know it sounds a little technical, but I promise you it's super simple. All it is a way to organize that messy list of numbers into a clean, easy-to-read table. You can basically think of it as our official chaos tamer. And boom! This right here shows you the power of just a little bit of organization. Instead of that long, confusing list of colors, we've got this beautiful, simple table. Instantly, you can see that blue is the most popular and green is the least. A story is actually starting to pop out from the numbers. And inside that table, we find our next key term, absolute frequency. Again, sounds fancy, but it's just the actual simple count. Seriously, no tricks, no complicated math. It's just the raw number of times something shows up. So if we look back at our color table, that number 10 next to blue, that's its absolute frequency. It's not a percentage, it's not some weird score, it just means exactly 10 people picked blue as their favorite. That's it. Simple, clear, and super direct. Okay, so we're making progress. Our data's organized and we can see how often things appear. But what's the typical value in a set of numbers? What's the center? That's the next big question we need to answer. And for this, we're going to use a tool you've probably run into a million times, the arithmetic mean, or as pretty much everyone calls it, the average. It's a great way to think about it. It's like the center of gravity for all your numbers. It gives you one single value to represent what's typical. And figuring it out is super straightforward. Let's say we have these 5 quiz scores. Step 1 is easy. You just add them all up. In this case, you get 430. Then for step 2, you just divide that total by how many quizzes there were, which is 5. And there you have it, 86. That one number is our average quiz score. So instead of juggling 5 different numbers in our head, we have one that gives us a pretty good sense of how that student is doing. It's a really powerful way to summarize things. But hold on a second. Does the average really tell us the whole story? Not quite. See, just knowing the center isn't always enough. We also need to get a feel for how spread out all the other numbers are. I mean, think about this for a second. Let's say you have 2 different classes, and they both have an average test score of 80. Does that mean they performed the same? What if in one class, pretty much everyone got a score right around 80, but in the other class, half the students got 100 and the other half got 60? The average is the same, 80, but the stories behind those numbers are totally different. And that is where our next tool comes in. It's called dispersion, and it's the measurement that tells you exactly that, how spread out or how clustered together your numbers are. It's what gives that average some much-needed context. This visual just nails it, doesn't it? On the left, you've got low dispersion. All the scores are tightly packed together. That's a super consistent group. But on the right, with high dispersion, wow, the scores are all over the map, from a 10 all the way to 100. The average might be the same, but the performance is completely different. And I gotta say, I love this analogy. Think about it like you're shooting at a target. Low dispersion, that means all your shots are in a tight little group, like a professional marksman. High dispersion, your shots are scattered all over the target. That just makes the whole idea click, right? So, okay, how do we actually measure this spread? Well, one of the most straightforward ways is with something called absolute dispersion. All this is the raw, unadjusted measurement of that variability, and it's given in whatever units your data is in. Dollars, points, inches, whatever. And to make that really concrete, let's just imagine we're looking at house prices. If the most expensive house on the street is $500,000 and the cheapest is $300,000, then the absolute dispersion is simply the difference, $200,000. It's just the raw gap between the highest and lowest points. And just like that, you've done it. You've built your first basic data analysis toolkit. You've gone from just staring at a confusing mess of numbers to actually having a structured way to figure out what they mean. So let's do a quick recap. You now know how to organize the chaos using a frequency distribution. You know how to find the center of it all using the mean or the average. And you know how to see the whole picture by understanding dispersion. These are like the absolute fundamental building blocks for making sense of any numbers you come across. So really, the next time you see a spreadsheet or a news report that's full of stats or even just, your own test scores, you now have the power to look deeper. You've got the tools. The only real question left is what story are you going to find in the data all around you?